In this video, we're going to talk about our latest plugin, Astrometry Delay, and how it completely overhauls and reshapes the concept of how a delay line could work in immersive environments, even if it's with monophonic, stereophonic recordings, or even with three-dimensional recordings. My name is Alejandro, and we are the Audio Brewers. Let's start by talking about how a traditional delay line works versus how astrometry delay works. In traditional audio, all a delay line does is grab a channel of audio and replicate it over a period of time. This replication happens as is because all it does is just grab the audio, buffer it, and then just repeat it as is. When we're talking about monophonic audio, this is a one-dimensional type of thing, so you just have one channel and you are just repeating it as is. When we're talking about stereophonic audio, you have two channels, one on each side, and these two channels conform all the two-dimensional spectrum that the stereo signal has until we reach the three-dimensional signals, where you will have exactly the same digital signal processor that you had in your monophonic signal one time or in your stereophonic signal two times. Here you will have it in your surround signal X times, one time per channel. And like this, you will acquire an exact replica of your sound signal being repeated over time. Now, this will give you very realistic results because you will have exactly the same signal being repeated over time. However, as you increase the depth of your signal from mono to stereo, from stereo to surround, and then from surround to whatever contains three dimensions, including height, things start to become a little bit more complex because as your signal grows, it might become busier. And what happens when you really don't want to repeat the whole signal as is because it's way too busy, but you just want to repeat just a piece of it? One of the solutions that developers have used to address this issue is to use filters. By using filters, all you're really doing is just grabbing a frequency range and repeating only that. So if your signal is way too busy, it's just a chunk of frequency that is being repeated. Astrometry works in a completely different way. In astrometry, there isn't a delay line happening in every single channel. For astrometry, there isn't even a mono or a stereo signal. For astrometry, there's only the three-dimensional sound field, which is this acoustic bubble where your head exists. Once the sound enters this three-dimensional sound field, astrometry will scan it whole and will just cherry-pick its loudest coordinates. Each of these coordinates is going to be converted into what we call an acoustic spot, and it is only this spot that is going to be replicated back in the form of a delay. So that way you are keeping your whole sound field clear of sound and you're just grabbing the loudest parts of your original sound and you're just replicating that into a random place around your head. Because this is a multitap delay, you're going to have multiple acoustic spots happening around your head. And this is what we call the acoustic constellation because it kind of resembles that. Let's just go to the DAW and explore how astrometry works. So I have here a very simple project. In this project, I have basically three tracks. One of them is in mono, which is this microphone where you have been hearing my voice from. I have another track here, which is a stereo track, which is coming from this XY stereo array. And finally, I have a first order Ambisonics track, which is connected to this microphone here that is on top of this tongue drum. So I'm just going to be showing you in a nutshell how astrometry works. I'm going to wear my headphones because this is going to be live microphones. And I'm going to proceed and go to my mono signal. So if I open my astrometry here and I have my mix on 0% so that you can just hear my dry voice. And now you are listening to my voice from astrometry. You can see that because it's a mono signal, my voice is in the front center. But if I were to increase the mix, this acoustic spot is going to be somewhere randomly around my head at 0.001 seconds. So if I increase the mix, let me just lower the feedback to 0. You can hear now that the acoustic spot is over there. I can recalculate that so that it is in a different position. And like that, the acoustic spot can be relocated somewhere. Let me just move the mix to 100% so that now you are listening to my voice passing through the delay. And with the voice through the delay, I can just change the time. And I can increase the viscosity so that the change in time is a bit smoother. So like that, now you can
change the time, and everything happens in a very smoothly fashion.
Now I can also add more taps. So if I were to add an extra tap, the acoustic spot is going to be somewhere else around my head. So if I add the tap, you can hear that now my spot is somewhere else. And I can also change the time of this acoustic spot and its position so that it sounds in another place. And I can like this add up to 8 taps. Let's move on to the stereo track and continue exploring what this can do. So now in my stereo track, again, I also have my Astrometry Delay. Let's just put it in 0% mix and with 0% feedback. So if I unmute this track, now you can hear that my voice is being heard from this set of microphones. And you can see that the microphones are being represented in the sound field in a three-dimensional manner, on the right and on the left. So if I were to increase the volume of the delay of Astrometry, this is the way it will rearrange the acoustic spots. I can recalculate their position so that they sound in another place. And like that, everything starts becoming more three-dimensional. I can also change the time. Let me just change it. To time. And change it to be like 1 second away. Equally, I can increase the feedback, so that you hear that it works as a delay, And again, I could also add more taps. So now you can hear two taps. And of course you can add up to 8 taps. Three taps. 4 taps, 5, And like that, you can hear that even if it's a stereo recording, the delay is not behaving as if this was a stereo signal. It's just behaving as if it was a signal happening in the three-dimensional sound field. Now, things become a little bit more complex when we move to the three-dimensional realm. Here we have our delay working in our Ambisonics track. And let me just put it back to 0 feedback and 0% mix. And now you're going to be listening to my voice on the Ambisonics microphone. And now you can hear me on the Ambisonics microphone. You can hear that my voice kind of moves around your head when I move around the microphone. And here is where things become interesting. As you can see, this is capturing a first order Ambisonics track, but Astrometry always works in 7th order Ambisonics. So if I were to dial in a little bit of the wet signal, you can hear that there is a defined acoustic spot being drawn in the delay. Let me just change the timing so that it has a little bit more of delay. 1/8. Okay. So now you can hear my voice being delayed from a first order Ambisonics recording into a acoustic spot in a 7th order Ambisonics sound field. I can change where this spot is located by recalculating. You can hear that my voice is now somewhere else. And depending on how I move, you can see that the acoustic spots are changing place. So if I were to play something three-dimensional, you can hear that the signal is more three-dimensionally arranged in a non-linear way. If I were to add another tap, and maybe let's just add a little bit of feedback. Sounds pretty interesting. Let me just add another one. And that's pretty cool. Let's just add another tap. Let's make it happen a little bit faster. And in a nutshell, this is the way astrometry works under the hood. Now, let's explore each of the controls because there is plenty of things that you can do here. And I just want to show you everything that is available on your hands with this delay. I'm going to change this project, and I'm going to load the project that we use for creating the music of astrometry. I'm loading this project just because it's a very simple project. It's just got 3 tracks. 2 of them are in mono, and the other one is in first order Ambisonics, so we can explore the delay in both cases. Let me just change the decoder so that it's in stereo, so that you can hear it in YouTube. And now let me just solo the first track and see what we've got here. Okay, so here we just have like the guitar just doing like a bass that is going to be looping. And this is a good place where we can explore astrometry. Let's just add an instance of astrometry. And as you can see, as soon as you insert it, you have all the taps enabled. Let me just disable all taps, and I'm just gonna keep tap number 1, and I'm gonna set the input to be mono, because right now I'm processing the signal that is coming from my guitar, which is a monophonic signal. So the first and most important part of astrometry is the XY pad. You have an XY pad where you can control the time in the horizontal axis and the loudness in the vertical axis of each tap, right? The time of each tap can be synced to the DAW, or it can be freely manipulated. When synced to the DAW, you have a time that goes all the way from 64th triplets to seconds, or you can set it free and make it all the way from 4 seconds to 0.001 seconds. And like that, you can control each tap. I'm just gonna keep it synchronized for the time being. And I'm just going to lower the mix so that I can hear only the dry signal. So if I press play, you can hear that the guitar is there in the front center, just like a monophonic the guitar will be. And now I'm going to start dialing in this delay and see where the acoustic spot of tap number 1 exists. Okay, so you can see that this acoustic spot is somewhere there. It has calculated somewhere there. And let's just imagine that I don't want it to be there. I want it to change position. All I will have to do is press on this button, and it's going to recalculate the position of this acoustic spot. Let's just say that I like it there on the left. But now let's just say that I just want to change the time at which this delay is moving. I can change the time by moving the time, and the change is going to happen immediately. That's because our viscosity dial is at 0%. If I increase this viscosity dial all the way to 100, you will notice that the changes in time are going to be much more lazy and heavy. And this is a really cool effect if you are working in sound design or something like that. Let's try it out. And like that, you can control how the changes in time happen. Again, you can do that by desynchronizing this from the DAW, and it still works very nicely. It can be either immediate or lazy. that's a pretty cool feature. And the cool thing about it is that it works per tap. So each tap has its own viscosity, each tap has its own time synchronization, and each tap has its own recalculation algorithm. Let me just set this back to 8. Let's just add another tab. All I have to do is click on this plus button, and I will add another tab. And you will see that tab number 2 is attached to tab number 1. This means that it's working in serial mode. If a tab is working in serial mode, it means that its timing is gonna start right after the previous tab has tapped. This means that if tab 1, for example, tapped, let's just say 1 second after the source, and if I set tab 2 to be another second, and it's in serial, it means that tap 1 is gonna happen 1 second after the source, and tap 2 is gonna happen 1 second after tap 1, and not after the source. And if I wanted to change that, all I will have to do is click on this button here. By clicking on this button, I'm going to be working in parallel mode. You can see that it's no longer attached. So for example, if I set this to be 2 seconds, tap 2 is going to be tapping 2 seconds after the source, meaning it's going to be tapping 1 second after tap 1, of course. So I can be juggling between it being parallel or in serial. Right now, here in serial, tap 2 will be 2 seconds after tap 1, meaning 3 seconds after the source. So if I try this, you can see that in serial mode, the tap 2 is just tapping 2 seconds after tap 1. But if I make it in parallel, now it happens 2 seconds after the source. And like that, you can make chains of taps that can be either kind of independent or depending from each other, or all of them depending from the previous one, or all of them independent from each other. So let me just add more taps and see what we can do here. So for example, if I add another tap here and it is synchronized, and I can add tap 4 and make it maybe parallel, faster, and then tap 5 by time, 2 seconds after, and then tap 6, and like that I can build my own taps. And if I press play, you can see that everything is happening depending on how you have placed it in the XY pad. And if you increase the feedback, it starts just working pretty cool. And you can see that each tap has its own acoustic spot happening somewhere around my head. And again, you can click on each tap and maybe recalculate the position of this tap. However, if you want to recalculate the position of all taps altogether, there is this master recalculation button. By clicking on it, you will recalculate the whole set of taps that are visible. So I can do that. And like that, I can just recalculate my whole acoustic constellation. Let me just make everything musical so that it makes a little bit more of sense. And let's not forget that you can also change the viscosity of all your taps so that the changes are smoother. And you can play with that too. Let me just try it. Like that, everything starts becoming pretty interesting, because everything you're doing has like a viscosity going on, but not only that, it's three-dimensional. Everything is happening in the three-dimensional sound field. Now, let's explore another thing, which is the dynamic constellation button. With dynamic constellation enabled, not only can you do everything that I have described previously, but Astrometry will keep your whole constellation just in constant motion to give even a better sense of depth of whatever is going on around your head. So if I enable dynamic constellation and if I press play, you will see that the acoustic spots will just keep moving slowly just to, give a little bit more of depth to your signal. And so this is a very interesting approach that you can do just to keep things moving around your head. However, if you are looking for interesting approaches, you can definitely use our modulators, which are available by clicking on this button. And you will see that there are 4 modulators that are open, and each modulator can be assigned to one or more controls. So you can see that as soon as I have enabled the modulators, you have 4 small buttons available under some of the controls. This means that these controls can be used with the modulators. Each button represents one modulator. So for example, if I were to assign the time of, for example, tap 4 to modulator 1, all I have to do is press the first button, and you will see that it's now moving. It's now moving from 0 all the way to 100, because the modulator 1 is from 0 all the way to 100. So if I were to narrow this down a bit more, you will see that you can control how this modulator moves. Additionally, you can also control how fast it moves. It can be from 100 milliseconds, which is pretty fast, all the way to 20 seconds, which is way, way too slow. So if I press play, you will see that because this has 100% viscosity and is in constant motion, you will have like a chorus effect going on. But that's not all. If you desynchronize this from the DAW, it's going to be running in a free tempo, so the changes are going to be even more interesting. Check it out. And like that, you can assign these modulators not only to one tap or to one time, you can do it like to many things at the same time. Let's just do something creative here. I'm just gonna grab this second tap and I'm going to add it to the second time, make it faster, but just in the beginning. And let's just say that tap 1 is going to have a variable gain and it's gonna go, like this, but a bit faster. And also, let's just say that our feedback is going to be also variable. And let's see how this sounds now. That sounds awesome. And this is what Astrometry can do for a simple mono signal. You have a mono signal right there in front of you, and you can just expand it all the way to a 3-dimensional state. But not only that, once your 3-dimensional constellation is ready, you can rotate it by using the spatial controls horizontally or vertically, so that you can just, reposition how you want everything to be happening. Let's try it out. You can see that everything happens in real time and everything happens 3-dimensionally. And right now I am decoding this to stereo, but if you were working in your Dolby Atmos project, you could definitely decode this to 714 or make a 3-dimensional object in 916, and it will definitely be all around you in a very, very cool way. Now, let's move on to our Ambisonics recording, which is also very interesting. I was here messing about with the tangent drum, and I have recorded this part using the tangent drum as well as Astrometry. I'm going to mute this Astrometry, and I'm going to add another instance of Astrometry Delay just to, work from the scratch. So again, as soon as I open Astrometry Delay, you can see that you have all the tabs in it, but, I'm just gonna start from the beginning. Let's see, first of all, without any delay, how this sounds. Okay, so as you can see, this is a first order Ambisonics recording. In the visualizer, you can see that each part of the sound is very blurry and somewhere around you, but it's not as defined as a seventh order Ambisonics recording. However, Astrometry works in seventh order, meaning that even though our signal is in first order Ambisonics, all the acoustic spots are gonna happen in seventh order. By doing that, all I have to do is dial in the mix, and you will see that the spots are gonna start appearing because this is a three-dimensional recording. Of course, you don't only have one spot per tap. It's gonna happen, somehow, depending on how loud each section, each coordinate of the sound field is. Let's just check it out. So as you can see right now, my spot was over there. And, because this microphone was inside this drum, you can hear that the signal of the tongue drum is like pretty much all around you. But the spot is very, very defined in one specific point. And that is pretty cool because that makes this delay work in a very, very well resolution sound field. So if I add more spots, let's just add something kind of randomly and see how this works with several spots. You can hear that this now sounds really, really cool because now Astrometry is analyzing the whole three-dimensional sound field that this thing was creating and is selecting the loudest part of the whole sound field that it was recorded using this first order Ambisonics microphone. And that is really, really cool. We could also do modulators here so that we just give it a little bit more of life to this thing. Let's just try something random. I'm just gonna set this to be independent so that I can control my first tap independently from everything. Let's just make it really slow. Now, this sounds mesmerizing and is with 0% feedback. What happens if I increase the feedback so that the delay keeps, coming? let's just try it out. I'm just gonna put it from the beginning because it's really cool. So you can see that this is a really, really unique type of approach to delays. But not only that, you also have presets. Presets are available. You can create them yourself, or you can use some of the presets that we provide. I'm just gonna try and do that and see what happens. I don't know what's going to happen, so let's just try it out. And this is pretty much what AB Astrometry is all about. We really hope that you enjoy using Astrometry in your stereo mixes, in your surround mixes, in your Dolby Atmos mixes, or even in your custom speaker array mixes. Remember that Astrometry works internally in Ambisonics, in 7th order Ambisonics, meaning that you can work in stereo or you can work in whatever you want, and you're always gonna have the best quality possible. We really hope you enjoyed this video. We really hope you enjoy working with AB Astrometry as much as we enjoyed creating AB Astrometry for you. Thank you so much for watching, and I will see you on the next one. Cheers.